Today's objective is angles and polygons. So you need to remember or learn that regular polygons have congruent sides and angles. So if we call something a regular polygon, that's what it means. They're all the same. So for a three-sided triangle, it would be an equilateral triangle. And I've put in the little tick marks on the lines to show you they're all the same. For a quadrilateral, it would be a square. You know what I'm missing? This little 90-degree angle, huh? Okay, but the tick marks show they're all the same. A pentagon, 5 sides. The lines, tick marks show they're all the same. Or you could just be told that it's regular. And I'm also showing you exterior angles. So if you extend the line from the side, that would be where your exterior angles are. We'll talk about them a little bit later. All right. So interior angles are on the inside, exterior angles are on the outside, and they're supplementary, the interior and the exterior angles. So when you have your triangle, you know that it's 180 degrees. And since they're all three the same, it would be 60 degrees for each angle. And you also know that a square has 360 degrees inside, and you know that the angles are right angles or 90-degree angles. Now you might not know that a pentagon, the total angles is 540 degrees, and each interior angle is 108 degrees. And if you didn't know that, is there a way that we can figure out a formula to tell us what the interior degrees of a regular polygon would be? Well, we know this is 3 sides, 4 sides, 5 sides. So let's make a little table. 3 sides, 4 sides, 5 sides. And the interior angles are 180, 360, 540. And when we were doing slope, we would find the difference. So the difference between 180 and 360 is 180. And 360 to 540 is 180. So don't look at that just yet. So how would we get to 180 from 3 sides, or 360 from 4 sides, or 540 from 5 sides? Well, people did a little bit of thinking, and they thought, well, what if we subtract 2 from the number of sides they are, and then multiply that by 180? Look, 3 minus 2 is 1. 1 times 180 is 180. 4 minus 2 is 2. 2 times 180 is 360. And 5 minus 2 is 3. And 3 times 180 is 540. So that's our formula. This n is the number of sides. And we just do 180 degrees times the sum, or times the difference of the number of sides minus 2. So let's try it for a hexagon. Here we have 6 sides. So we wrote our formula, 180 times the quantity n minus 2. That's the word I was trying to think of, quantity. 180 times 6 minus 2, or 4. And what would that be? Well, 180 times 2 is 360. So times 4 would be 720. So a hexagon interior angles are 720 degrees. But how do we figure out the degrees for each interior angle? We know the total is 720. Well, 180 divided by what is 60? And 360 divided by what is 90? And 540 divided by what is 108? Have you thought of it? It's the number of sides, isn't it? 180 divided by 3. There's 3 sides on a triangle, 60 degrees. 340 divided by the number of sides, 4, 90 degrees. And 540 divided by 5, 108 degrees. Let's do a little problem. What is the measure of each angle in a regular octagon? Well, octagon has 8 sides. So I do our formula, 180 times 8 minus 2, which is 6, is 1080 degrees. And that's for the total octagon. So now just divide it by the number of sides. 180 divided by 8 gives us 135 degrees for each angle. All right, now let's talk about the exterior. So here's an equilateral triangle. You can tell because of the tick marks. And I've drawn lines. I've extended the sides and made lines. And you know that the interior measure of an equilateral triangle is 60 degrees, because we talked about that a minute ago. And so we want to find the measure of angle 2 in this equilateral triangle. Well, I wrote a little bit and then here I did the math. So when I extend a side, I get an exterior angle. So I just extended the side. I did it in red. And this is always a straight line, and the interior and exterior angles are supplementary, so they equal 180 degrees, always. So the measure of angle 1 plus the measure of angle 2 will give us the 180 degrees. Well, you know the interior is 60, so 60 plus, I'm going to substitute for x now, equals 180 degrees. Subtract 60 from both sides, we get the exterior angle is 120 degrees. And this is true for all of the exterior angles, okay? Because all of the interior angles are 60 degrees. Let's find the measure of angle 2 in a hexagon. Now I remember that hexagon is 6 sides because the word 6 has an X in it and the word hex has an X in it. That's how I remember that. So I'm going to, here's a little thing if you want to write it down how to do it, okay? And there's 6 sides in my hexagon. So first I'm going to find the total interior measure, then the interior measure for each angle, find interior angle measure, and then I'll find the exterior because it's supplementary. So 180 minus the quantity of n minus 2, 186 minus 2 because there's 6 sides, 180 times 4 is 720. So there's 720 degrees total inside of a hexagon. And now to find the individual degrees, I do 720 divided by 6. Well, you know that 6 goes into 72 12 times, then you can just add the 0. So it will be 120 degrees. Now the measure of angle 1 plus the measure of angle 2 is 180 degrees. Well, we know measure of angle at 1 is 120 degrees. So 120 plus x is 180, minus 120 from both sides, we get x equals 60 degrees. It's the opposite of a triangle, isn't it? I didn't know that. So there's our our interior individual angles in a hexagon. No, Debbie. I'm sorry, that's our and I said Debbie too, I said Mrs. Bowden, huh? That's our exterior. Let me write that down. That was funny. Okay. 60 degrees is the exterior angles because we said right here the interior was 120. I'd like you to do something that's kind of interesting now. Let's sum the exterior angle measures. Well, in the triangle we said it was 120 degrees, and there's 3 exterior angles because there's 3 sides on a triangle. 120 times 3, 360. You know, in a square the interior is 90, so the exterior is also 90 because that makes 180. 190 times 4 is 360 degrees. We just said in our hexagon that it was 60, and 60 times 6 equals 360 degrees. A coincidence? I think not. The sum of the exterior angles in any polygon is always 360 degrees. Always. So knowing this, can you think of another way to find a polygon's exterior and interior angle measures? Something to think about. That's it.